in example 1, we have the sine of A equals 4 over 5. With this information, we know that in whatever triangle we're working with, we have a reference angle named A, and the side that is opposite of A is 4, and the side that is our hypotenuse is 5. So what we need to do here is we must include a right triangle so we can find the other missing ratios. So when you draw this triangle, it's okay if it's not perfect. All right? It doesn't have to be to scale. As long as we have a general idea of which side is which and what reference angle we're using. I'm going to include my reference angle A at this corner here. Now, when we're looking at this triangle, opposite of A is this side here. The hypotenuse is this longest length here. And the side next to A or adjacent to A is this one down here. Knowing that the sine of A is 4 over 5, we know that 4 is the opposite length and 5 is the hypotenuse. So now our goal here is to figure out what is the length of our adjacent side. This is where we're going to use Pythagorean theorem to solve. So here we know that it's a leg squared plus leg squared is equal to hypotenuse squared. I'm going to let A represent my adjacent side, B represent my opposite side, and C represent my hypotenuse, because C and hypotenuse, they like to stick together. So now we want to figure out what is the value of A. So solving this here, I'm going to plug these values in. We get A squared plus 4 squared is equal to 5 squared. And at this point, we are pretty comfortable with these types of problems and how to solve them. We end up getting A squared equals 9. And taking the square root of each side, we get A equals 3. Very nice. So that tells us that the side adjacent to our reference angle is equal to 3. Now we have our adjacent. We've got our opposite and our hypotenuse. So we can figure out cosine of A, which is adjacent over hypotenuse, or 3 over 5. And tangent of A is opposite over adjacent. So this gives us 4 over 3. Now cosecant is the reciprocal of sine, so we get 5 over 4. Secant is the reciprocal of cosine, so this gives us 5 over 3. And cotangent is the reciprocal of tangent, so that gives us 3 over 4. And these values will give us our final solution. Excellent. So let's look at what just happened here. We were given the sine of A, and from that we included a right triangle and drew in the information where A is our reference angle, 4 was our opposite, and 5 was our hypotenuse. We must figure out that third side in order to get the remaining ratios. So we used Pythagorean theorem to solve for that third side. Once we did that, we used SOHCAHTOA to get cosine and tangent. And we used the reciprocals to get the remaining 3 ratios.